Okay guys, so what's up guys? Welcome back. So I'm gonna do a little bit of a redstone tutorial. Um I haven't uploaded in a while because the ops got to me, so I have to be really quiet or else the ops will hear me again and skin me alive again. Okay, so in this basic redstone tutorial, um so what do we have? There's this thing called redstone dust. You can wire it, it's like you can whatever, I don't really give a fuck what you do with it. But just know that this lever, it's like if you click it, it stays. And it powers everything around it with full power. Like anything around it. It can even power underneath because it's going through the block. You can power blocks kind of. Unless it is a transparent block. You can't. Like this works. But this won't work. You can't pass power through transparent blocks. It's all about propagation. So this is what I'm trying to demonstrate here. You can go in whatever directions. Target blocks can redirect the redstone. So like normally, if you branch redstone out, it like stops there. So like let's say you wanna repeat it like that. It's not gonna point towards that block. Well, if you have a repeater, it's gonna point. But if you have a block into a repeater, it won't point. So what do? You have to redirect this redstone. So you use a target block. Now the repeater is powered. So that's what I'm trying to showcase here. They can go down, like down from their original place, and they can go up. I don't really care. But they get cut off if you put a block here, see? Now this one's not powered because it's blocked off. It can't propagate. So here I'm showing off that they can die off. See how it can slowly die? Now this is like very weak power. If I continued, see it just turns completely off and it doesn't reach the end. But if you put a repeater, it takes it and then becomes like a buffer. It like extends it. However, there's a small delay. It's called one tick. In Minecraft, there are 10 ticks per second. So if this you want to do a 10 tick clock, it's like this. This is the fastest you can ever go, pretty much. So you can change how fast it will react to the information it's given, and it also holds it for that long. See, 1, 2, 3, 4. See, it doesn't just react in 4 ticks, it also holds it for 4 ticks. So it kind of has two. So here's a clock. So what a clock is, it's just a repeater going into dust, feeding it to another repeater, going into itself. So it's like in a circular order. You power it really fast, and then that's what. So this is what I'm showcasing a clock, and it's into the different lengths. So this is 1 tick, 2 tick delay, 3 tick delay, 4 tick delay. See how it's like they take different times to react to this information, which is all synced up, but then this becomes unsynced because they're different delays. So I'm showing how you can power blocks. So it can go up, it can power a block up, you can power a block through it. So this works because you have to. This is called hard power, and this is soft power. So if you you can hard power a block with a repeater, and it can receive that output in whatever direction, but you can't soft power it. You can also hard power receive it. Yeah, you see what I mean? And if it's this, you can't receive anything at all, or you can't send it. Glass. Glass, there are lots of transparent blocks. There's another transparent block called glowstone. Like, you can prove it's transparent by seeing if it cut off the signal. See, it doesn't. If it was a regular block, it would cut off the signal. This doesn't. And also something interesting that, let's say you have a lamp, like a redstone lamp. Something interesting about them is that they take a bit to turn off. So what the industry does is they get iron trap doors that react instantly and then they bring some resource pack that makes them look like lamps. Now it's an instant lamp, but it's not really. I'm just gonna use lamps because it's easier to place and to show you idiots. I mean, yeah. So, so a redstone, you can click it to go in dot mode or cross mode. In cross mode, it will, um, it can power stuff underneath it, and it can power this piece underneath, and it can power the sides. So I'll prove that like this. So I don't know how I'm gonna power this. Although I'll also power the bottom, but yeah, and then now this will turn off. Well, not this because this is powering that, but you get the idea. So it's like when it's in dot mode, it doesn't power the ones up around it, but it powers the ones below it because it's through a block. Yeah. So I'm gonna continue the tutorial. 1 second. Okay. So I'm showcasing that, and now I'm gonna introduce a component called torches. They they give you the opposite of what's given in, and they take a tick to process. So let's say you want the opposite. So this dust is on, but the input is off. Now if you open the input, the output would be off, like it's an inverter. So as you can see, this is just a clock showcasing it so that it turns on and off the main signal, and it's showing how it's reacting to the complete opposite. And what happens to torches specifically, I'm going to show you how to bypass this later. If you power them really fast, see how they burn out? And they take a bit to respawn. It got burned out and now it's working again. Like, that fucking sucks. Um, I'm showing you how to pass. This is a 2 tick clock. It's going back every 2 ticks, so that's 5 hertz. If you put it through a 3 tick repeater, like you want to make a 3 tick delay, a 3 tick repeater won't work because with a 3 tick repeater, it doesn't just delay the input, it also holds it for 3 ticks, and that doesn't work in the 5 hertz system. Because 3 ticks is like 3.33 hertz, I think, and then the 2 ticks is 5 hertz. 5 hertz is the fastest you can go in Minecraft, pretty much. Because 10 back and forth doesn't really work because I said so. Okay, so wait, I might be a bit confused. 2 tick clock. Okay, so hertz is very controversial. It can mean how many times it updates per second, which is 5. But also, but if you want to count how many times it turns on per second, it would be 2.5. Because it's 1, 2, 1, 2, half, 1, 2, half per second. But if you're counting how many times it updates from on and off, it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, I'm kind of autistic. So this is how you pass a 3 tick through a 2 tick pipeline system. So you get a 2 tick repeater and then 1 tick repeater. And you're like, aren't these interchangeable? Like 1 tick and then 2 tick? No, because Minecraft is really weird and buggy, so I don't know why that doesn't work. It's just a stupid update order system in the game. But this does work, so it's just a cool thing to keep in mind. Okay, I'm showing how you can cut off wires and how glass or any transparent block can let it through. Here's how you can go down, right? But what if you don't want it to go down? You can have a transparent blocks. Transparent blocks don't let it down. However, they let them up, but they don't let a signal down. So this could be cool for like instant diodes. A non-instant diode would be like a repeater. See, look, if you turn this on, it doesn't go backwards. But you turn this on, it can go forward. But that takes a tick, and that's not cool. So this is like an instant diode. And I'm showcasing how you can't hard power transfer block. I'm showing diode system. Here's another clock system. This is like a tower. You can make towers by keep putting transferring blocks. And actually, I'm going to turn on a resource pack I made that like shows the strength of every signal. So it starts out on 15, and then as it branches out, it decreases. So if you keep decreasing it, it turns into 1. And what would that do if you continue? Forget this weird machine. If you kept continuing, it would be 0, and these repeaters wouldn't be powered. So what you can do is you can repeat the signal by there's this machine that you can like hook it back. Um, if this signal was 1 and this was 2, you don't need this to be a full block. Actually, you could just continue up. However, this won't be powered in this case. Other cases would be example like case 1 is when you power it from here, right? It won't power the top. Case 2, if you power it here, it will power this top. So there's no need to make this a full block. Because if you make it a full block, it can power this block, which goes into here. But you don't need that necessarily. So that's what I'm talking about. And I want to show you a sync system, how to keep them synced. Because right now, normally, let me not make these 2 ticks because you don't know that yet because you're kind of slow. Okay, let me make a clock. Okay, so this will take 1 tick because it's from the original power source. But in the extended one, this takes 1 tick. So then this would take 2 ticks in total because this will be 1, but this will be 1, 2 to pass it up. So let me actually I should make this a full block so that you can actually see. See how they're not updating at the same time. Like it's that and then that. It's really fast, so you kind of have to like open your eyes. So if you do this, if you make the bottom one a tick more than the top one, now they're exactly synced up because this will take 1, 2, and this will take 1, 2. So it takes the same amount of total delay. Okay, comparators. Comparators have 2 modes: subtract or compare. They have 2 inputs, a back and a side. If you don't have a side input, the mode does not matter. It does not change the functionality. So what it does, so you know how repeaters, what they do is they literally repeat the signal. So like they extend it. So if this is 14, no, I'm so stupid. If this is 14, it turns back into 15 no matter what this is. It turns back into 15. However, for comparators, 15, 14, it holds it. It keeps that. So it's like 14 and it stays 14. So that's pretty cool. What comparators also do, they can like um, let's say you have like power sources. It can read like containers. So that will make 4 because it adds this amount of stuff in it. It will make 4 signal strength. So there's like a bunch of barrels. So 15 would be just all full. It's bullshit. There's a way to add more signal strength than it's allowed with like cool hacks and stuff. This is like stack diamond swords to like hack it. So this technically holds like 256, but as soon as it turns into dust, it turns back into 15. So if you only use comparators in your system, you can technically. I can prove this by doing 256 minus 255. Oh, you actually don't know how to subtract yet. I'm just a bit getting ahead of myself. Okay, so compare. What does that do? I'm going to use barrels from now on to choose which signal strength I want. Okay, so let's say you have 15 in the back. Or no, let's say you have 12. 12. 12, and then it passes through 12, right? And let's say on the side you have 6. It stays 12. But let's say this was also 12. It stays 12. But what if it was a bit more than 12, even 13? Oh, it blocks off. So what this is if the side input is greater than the back, then don't pass the back. So it's kind of like, yeah. So if it was 15, it would always unpass no matter what. Even if this back was 15, Oh, never mind. I'm a bit slow. Okay, so yeah. Okay. So subtract mode. It's basically the back signal minus the side signal. So let's say you have 13 minus 7. You don't know what 7 is? 13 minus 7 is? Oh, it's 6. Okay, pretty straightforward, if you ask me. So now I can prove it's called HSS, this high signal strength. You'll never need to use it, but I just want to be cool and show you. So this 250, you can't put it into signal strength because it resets. So it's 256 minus 255. See, it's 1. Normally, this proves it because it's actually a real thing. I'm not just making caps, facts, caps. Um, yeah, there's not really anything else for me to show you. So you can make logic gates. So, so what an OR gate is, this is like the simplest kind of gate in Minecraft. It's just a wire. Because backflow doesn't matter in Minecraft. Normally it would just short circuit itself. But Minecraft has two states, so you can't really short circuit it. It doesn't really make any sense. Okay, so here. So what Minecraft is just a NOR gate simulator. Any NOT gate, this is a NOT gate. Inverter is literally NOT gate. It's just a NOR gate with its second input off. Am I right or am I right? So everything is a NOR gate, no matter how many the inputs there are. NOR gate just means if all the inputs are off, it's on. That's literally all of Minecraft. So how do you make an AND gate out of this? Well, if you follow De Morgan's law, you can know that. So this right now is an OR gate. If you invert it, it's an OR gate, right? Almost there, right? We're almost there. But if you invert the inputs, what is this gate? That's an AND gate. So if you invert the output back into an AND gate, this is our Minecraft AND gate. See? None, none, on. So to simplify that, so it's invert inputs or it invert output. So to simplify that, what you can do is you have two inputs here. You invert them because it powers the block. You OR them because these two can both influence this. And you just output that. Simple. Logic gate. You can make this much smaller with comparators. Comparator tricks. Um, let's say you have a back input and a side input. So back and side. It's not quite an AND gate. It's almost. So let's just invert this side. Well, you don't really need, again, repeaters. I'll just double. So now it's an AND gate. This is literally an AND gate. It's a 3-block AND gate. You can't really put torches right into the side. I don't know why, but you can put repeaters or comparators or I don't know anything. You can't do this either. Yeah, so that's an AND gate. Oh, repeater locking. Okay, so what you can do is you can actually power a repeater from the side. So let's say you have an input, it can pass through, but let's say, boom, the side locks it. Oh my god! So now what happens if we change the back? It's stored in this block now. This back does not do anything. So if we turn it off, store the off state, oh my god, it stays off no matter the input. If we store the on state, oh my god, it stays on no matter the input. You can make registers out of this. You can store a bunch of bits. Let's store a bunch of bits. See, just like that. How do we stack this? go like this, you go like this. Slash us stack 7. Now we stacked it 7 up. And we make a tower for the side signals. See how very simple components. They're all very simple components. So now we can like store it. So let's say we want to store 10101010. Off is 0, on is 1. So 01010101. Lock it. Now no matter what these inputs are, I can make them whatever I want. The